So thank you very much for having me. It's really been a wonderful event. I love my espadrilles. I already tweeted them. I think they're very cool, and I made sure I was matching them. So thank you very much. So I am actually an aerospace mechanical engineer by training, believe it or not. I started working at Grumman and at NASA on future missions around Jupiter and the Space Shuttle program, believe it or not. But through my journey, I was in IT for quite a while. I was at IBM for many years. I was a VP and Chief Technology Officer there. And as I started helping IBM understand the Internet of Things, what we were talking about is how do we ensure end-to-end trust and security with the Internet of Things. If somebody has an implanted pacemaker and the doctor or another device can connect to it, how do we make sure that they're trusted? How do we validate their identity? How do we make sure that the software isn't colluding against the application and the humans? So in 2016, we started working with IEEE. Who's heard of IEEE? Excellent, almost everybody, wonderful. So for those who haven't, it stands for the Institute for Electrical and Electronic Engineers. It's been around for many, many years, over 100 years, 420,000 members around the planet. And we work together as volunteers to make standards to make electronic and communication things safer. So starting in 2016, we had a workshop with IEEE at George Washington University in Washington, D.C., co-sponsored with the National Science Foundation, and created this framework called TIPPSS for IoT. It stands for Trust, Identity, Privacy, Protection, Safety, and Security. All the things that we as software developers and hardware manufacturers and healthcare providers and humans, citizens and patients, need to worry about. So as I look at it, I feel that our increasingly connected world leveraging IoT creates great value. You know, I have my Fitbit and it connects to my phone and it updates my electronic medical record someday. Cars are going to talk to each other and to the bridge to make sure that they're safe when we have autonomous vehicles. But with this great value also comes great risk, because all of this is potentially hackable. So what we must do as part of the solution is to ensure that we're developing with trust, identity, privacy, protection, safety, and security in the devices, the systems, the solutions, and for the people. So I'd like to go to a video now to look at an aspirational view of healthcare. And it's late in the day, so I thought a movie would be fun. Let's cut to the video. ¿Cómo se dice en español? Gracias. So here's a grandma, and she's looking at her heads-up mirror display, very cool, in her bathroom. Shows the weather where she's going. And she puts on her glucose meter. And oh, look at this. Her mirror knows her glucose level. What do you think the privacy and security elements are of a mirror? I don't know. Oh, her refrigerator knows. Did anyone hear of this spamming refrigerator a few years ago? Okay. So all these things know all of her healthcare data. Very interesting, or some of it. Oh, there's a heat wave alert where she's going, high asthma risk. Oh, her daughter knows that her grandson might need his inhaler, so she brings it with her. Good mommy. Then the local hospital where the grandma is going and near where the little boy lives is looking at the environment. Oh, they get an alert about the weather. Heat wave alert. One additional care team required. So then they look, and they take some people, and automatically they're on call. Oh, this is why people turn off their phones. So then Grandma gets, oh, hello, Grandma. She comes. Everyone says hi. They're out in the field. The device on Tyler's arm says how he's doing, his heart rate, his blood pressure, and tells the mommy, low asthma risk. Very cool. Then, uh-oh, Grandma, I'm a little dizzy. No. Are you okay, Mom? No. I'll be fine. Son-in-law, he talks to his phone, says, what's going on? They do a little triage. Based on the symptoms and where they are and the traffic and the wait time, they tell him where to go. Very cool. Bye, Grandma. Feel better. Then they have to transfer medical records, and she just puts her fingerprint on the iPad, and boom, all the data gets transferred. This is make-believe. This is in the future. Then this is the hospital where she's going. Geisinger is the one who runs it. There's a new patient. The doctor comes in to see her. And so he looks at her vital statistics. Blood pressure is okay. This is what it usually is. But you're a little dehydrated. So the nurse gets an alert. We need an IV pump. She puts it down. It finds all the pumps so that nurses can't hide them, which they usually do, so they can find them when they need them. Now look at these. Ooh, aren't those cool? I want those glasses for Christmas. And then they send a note to Grandma. Feel better, Grandma. Aw, it's so easy to get data into the hospital. I wonder how easy it is to get it out. Or I wonder if they can go in and then go horizontal, like in the target attack. So here is her primary care physician on the other side of the country at Geisinger. She's actually at a Kaiser Permanente area. He said, you'll be fine. Stay hydrated. So everyone's happy. So they use audio and video for telehealth. They tell the hospital they're happy, happy family. And this is the job I want if I ever really retire. The hospital looks at who likes them, and they like them back. I do that every day. And here we are. Grandma's fine. Oh, everyone gives her a hug. Very nice. Thank you very much. Connecting people to a healthy future. So this is an aspirational view of healthcare, automatically sending medical records around just with your fingerprint, being able to find the devices you need, analyzing people real time, your children, and then seeing if they have any medical risks. So there's so much opportunity, but think of all the risk. Think of all the places that medical data is and how many times it's an attack surface. So as we look at the great value and we look at the great risk, we also look at the technologies that can help us get there. So advanced technologies and integration of a lot of these different data sources will create or portend the future. The Internet of Things, blockchain. I do a blockchain consulting. I'm also on the editorial board for Blockchain and Healthcare Today, and I'll talk more about that. It's an open peer-reviewed research journal. You can read it all for free to look at use cases for blockchain and healthcare. Machine learning, I worked on the Watson strategy at IBM, cognitive computing, artificial intelligence, big data, which is sometimes big data, or it's sometimes a lot of little data that makes big data, and augmented or virtual reality. All of these together are going to help us create some of these cool applications and create lots of data. So who's heard of Brontobytes? 10 to the 27th, isn't that a cool name? So that's where the dinosaur is. So Brontobytes of data, billions and billions of devices. This says 70 billion. One of the presenters yesterday was noting that Intel is saying there are going to be 200 billion devices, in the next year or a few years. A lot of devices, a lot of data, a lot to protect, a lot to protect. Healthcare is one of the key areas that I've been looking at because when I was first starting the Internet of Things strategy at IBM, and we started working with ARM. Who knows who ARM is? Have you heard of ARM? Very good. So ARM actually designs the intellectual property for the chips that are in 95% of the cell phones around the planet. They're in Medtronic, insulin pumps. Actually, when I was doing this project, one of the gentlemen I worked with came running into my cubicle. I didn't have an office. We had all open space. And said, "They keep me alive." I was like, whoa, what are you talking about? I'm in a PowerPoint here. And his insulin pump was on the list of devices that ARM actually is embedded in. So it was very important to talk to ARM as we looked at end-to-end trust and security from the device to the cloud and back. So this healthcare data sharing and medical IoT usage is really growing. If you look at why, one of the things we have here, a quote from one of the doctors in CIO magazine, actually a health IT person, "We've killed more people because we didn't share data than because we did." What if there's data on allergies that they don't have? What if there's data on prior episodes, family history, new genomic data or new test data that actually can help them save a life? That's the opportunity of data sharing. And 87% of health organizations plan to adopt IoT technology by this year, by 2019. And some of it is because we're using it. We use a Fitbit, or we use an Apple Watch, or we use iHealth, or whatever. So sometimes the patients are actually introducing it, and it can bring value if they can get that data. In the United States, we've been focusing on this data sharing problem, and a few years ago, we had a project called the Cancer Moonshot. It was named after Joe Biden, the Vice President of the United States at the time, his son who passed away of cancer. And so it was the Joe Biden Cancer Moonshot meeting, and it was at Howard University in Washington, D.C. And so after that meeting, they created, the NCI is the National Cancer Institute in the U.S., they created a blue ribbon panel on enhanced data sharing. Blue ribbon panel is like very fancy. You get a blue ribbon, like when you win something, you win to be on this very important working group with very high-level people from medicine and from health information technology. And so they have an enhanced data sharing working group. Part of it is a cancer informatics for cancer care working group that I participate in. And we're looking to build a national cancer data ecosystem. There's a genomic data commons that's led by Bob Grossman in Chicago. A lot of really cool things going on. I also am on the computational approaches for cancer workshop that goes on at the supercomputing conference every year. Any of you go to the supercomputing conference? It's really cool. Big fat supercomputers, great network. And so what we're looking is how we can better leverage information technology in healthcare. So as you look at why, one of the things we talk about is precision medicine, or precision oncology, or personalized medicine. It all means the same thing. Precision oncology is for cancer care. But the precision or personalized piece is that we make it special for you. And what do we leverage? We leverage your genomic data, perhaps family genomic data, clinical and fundamental research data that's going on around the planet in many languages every day. And even though doctors are brilliant and they might know multiple languages, they probably don't know 170 different languages for all the countries where there could be that much research going on. So computing can help with that, artificial intelligence, cognitive computing. Clinical care data, it could be image data, like an X-ray, or it could be they take a picture and you look a little yellow, you look a little jaundiced. It could be text that they write, which is actually not really very textual sometimes. Doctors don't have the best handwriting. But it could be text. It could be numerical, test results. It could be video, like that video we saw from telehealth with the primary care physician on the other side of the country. He was in Pennsylvania. The grandma was in California visiting the family. Audio, etc. Also, IoT wearables. I just keynoted an event in Boston, Massachusetts on medical IoT and medical and IoT wearable devices. And one of the things that is starting to happen, which I'm very happy about, is that the New England Journal of Medicine, which is a very popular, well-respected journal in the United States, has been talking about RWE and UDI, just what we need more acronyms. But it stands for real-world evidence. So the data you're getting from our real devices that we're wearing, and then unique device identifiers. So we're starting to get into, how do I validate the identity of this device? How do I make sure it's that person's device? When one device is talking to another, when a glucose meter is talking to an insulin pump, how do you know it's that person's glucose meter? It's not the one of the person sitting next to them. How do we make sure? So we want to make sure that we're leveraging these unique device identifiers for that reason. And life sciences and environmental data. Like you saw, the mommy could see from Tyler's watch, what his heart rate was and things like that, and could also knew that there was a heat wave alert because of the weather information. Very interesting. The hospital knew from the weather information, heat wave alert. More dehydration, which is what grandma's problem was, as well as potentially higher risk of asthma attacks. So very interesting. What we do is want to leverage all this data in real time. Oh boy, right? There was just another conference presentation here with the fire hose. Anybody here for that one? I love that picture of his son 20 years ago, or maybe 18 years ago. And talking about the fire hose of data, this high velocity, high value, high volume, and high veracity, a lot of uncertainty in it. Is it really the data that you think it is? So there's a lot to do in this space. Smart cities are also going to be leveraging a lot of data, creating and leveraging. There'll be an interconnected IoT-enabled system of systems. There are smart grids, smart homes and buildings. I developed the smart building strategy at IBM. Connected healthcare, as we've been talking about. Connected citizens looking for information. They could be connecting to the transportation system, saying, where's the bus? The bus, the street is closed. What do I take instead? There'll be vehicle-to-vehicle communication, vehicle to infrastructure, so the vehicle's talking to the bridge, vehicle to healthcare, because it can be checking when you sit in the vehicle, it can check your temperature, it could check your blood pressure, It can sense if you're drunk. If it's autonomous, might not matter, but it could, vehicle to people as well. And then industrial and other safety mechanisms. So what I envision is that there'll be a mesh network with a lot of this information being shared, and it still has to be protected. Think of all those attack surfaces we just talked about. So many. And how many actual attack surfaces are in one vehicle? Many, many attack surfaces. So what we need to think about is what we can enable across this system of systems, but also how we protect it. So we need to think of the trust, the identity, privacy, protection, safety, and security. Let's talk a little bit more about that. So as we say, TIPPSS is an imperative for smart cities and for connected healthcare. The T is for trust, allowing only designated people or services to have device or data access. If there's a doctor leveraging a service connected to electronic medical record, trying to get into a pacemaker, how do you know that's the doctor? How do you know that doctor is still certified? How do you know they're still supposed to be connected to that EMR or EHR? How do you know that they should be looking at that patient's information? I was speaking to somebody at Carnegie Mellon University, and his wife is a doctor at University of Pittsburgh Medical Center, and he said that she told him that if you can get into the electronic medical record system, you can see any patient's data. Right? Oh my gosh, seriously? So we, as the software developers, need to worry about how we're doing this correctly. How do you validate the identity of people, services, and things? How do you do that? And how do you make sure that the right human is connected to the right device? How do you ensure privacy of the device? Personal, sensitive, and private data needs to be kept private. How do you protect the devices and the users from harm? It could be physical harm. If somebody hacks an insulin pump, they could actually kill you, a pacemaker. Financial harm to the company, as well as reputational harm to any of these organizations. Providing safety and also security. I also work for the NSF Cybersecurity Center of Excellence, so I care a lot about security and think about it every day. So that's what TIPPSS is. Now, I didn't want to show too many videos, but if someone's interested, you can take a picture of this and look at some of them. There's a video of a couple of guys that actually hacked a Jeep while it was driving on the highway. Has anyone seen that one? Yep, very interesting and very scary. I showed it at an event a couple years ago, and there were a couple of guys like watching like this, and I thought, wow, they're such good listeners, right? So afterward, I was leaving, and their eyes, you know when people's eyes are this big, they're thinking something. I said, you're such good listeners. They said, we have that car. I said, oh, go get the engineering change. Go get the firmware update. Then I saw one of the guys 9 months later. I said, how's your car? He said, it's in the garage. I said, you can't live like that. All this stuff is going to be connected. You have to stay on it. And he's a technology guy. You know, he works for a networking company. They can hack into your home. They actually hack scientific devices as well. I work a lot with the research and education community. And often the scientists will say, I made this device. It's the only one on the planet. Who would want to hack it? So here's an example. You might have heard the LIGO project where they were analyzing and looking for the neutron star collisions and understanding black holes. So when it was about to happen in Australia, the telescope was far away from where the people were, and they were trying to get the server to move the telescope to aim at that place, and somebody had hacked the server. They had to drive out to the telescope and then physically get it moved. So anything is interesting. In healthcare devices, the US Food and Drug Administration, or FDA, actually announced a couple of years ago 465,000 pacemakers that were originally made by St. Jude Medical, which is now owned by Abbott Laboratories, are hackable. 465,000 grandmas and grandpas with pacemakers. They needed to go in and get a firmware update. How many of you think your grandmother knows what a firmware update is? Yeah, that's what I thought. So I'm Italian. This is how it would go in my family. Grandma, we have to get you a firmware update for your pacemaker. Oh, firmware. That's like al dente? Ah, good guess, Grandma. Firmware is in between hardware and software. Let's go get you a firmware update, then we'll go out for pasta. How many people are going to help these humans with this? Make sure that they get this. So we have to bake in this TIPPSS from the beginning. The US Department of Homeland Security announced in March that there were 20 new Medtronic devices that actually are hackable with a low skill level with adjacent access. You don't need to be a rocket scientist to do this. And adjacent access is within 25 or 50 feet. How many people are within 25 or 50 feet of you now? Do you trust all these people? If they paid to come in, maybe. But you just don't know. There are so many bad things that can happen. So security and privacy risk and concerns are increasing. The good news is that the governments are starting to take some action and announce some things and pull people in and say, you have to get this fixed. But now we have to make sure we're baking it in from the beginning as the developers, and we're fixing it as well. So what could possibly go wrong? We just talked about that. We need to protect the humans. So my top concerns, as I mentioned, are healthcare and vehicles, because healthcare devices or vehicles, if you hack them, you can quickly kill somebody. You can turn a car off. You can take over the steering wheel. You can tell the insulin pump to give them more insulin. You could turn off a pacemaker. Very terrible stuff. So protection is needed at the device level, in the hardware, the software, and the service level, because they're all hackable. So there are physical health and safety risks, financial and reputational, as we said. They can steal the data, but they can change the data, which is worse, right, in some ways. They can steal your identity if they steal the data, but if they change the data, they can affect what's happening with your devices or in your car and tell it to go the wrong way. And then a loss of privacy. So we need a defense in depth strategy. The hardware level baked in, the firmware level kind of baked al dente, software and service level. And we need to evolve the policy and the culture to expect this. And there was a KPMG article a couple years ago that talks a little bit more about this. So as we started developing this strategy with IBM and IEEE and the National Science Foundation, they started asking me to publish more about it. So in 2018, there were a couple, in 2018 last year, there were a couple of articles that came out enabling trust and security in general for Internet of Things, and then wearables and medical interoperability to get very focused on that. So now I want to talk a little bit about blockchain. I'm going to come back to the TIPPSS piece. How many of you are coding in blockchain? Coding blockchains. Okay, very interesting. Are you worried about the consensus algorithms and the 51% rule? Yes? Raise your hand. No, keep it down. Okay, you're not worried. I am. So blockchain, as we know, is digital distributed ledger technology. It's really should be used as just the ledger. And there's a group, if you're doing any work in connected healthcare, there's a group called Sovrin, S-O-V-R-I-N, that does really cool stuff. And we were talking to them on the identity and trust side, and they said, the CTO, Chief Technology Officer, said, keep all the data off the blockchain. It really should just be a ledger. Because also, if you want to stop access to the data, like if they have the right to be forgotten or somebody hacks the blockchain, you can just cut the connection to the data, which is really smart. So it enabled, but the cool thing about distributed ledger technology, the DLT, is that it enables data sharing without essential authority. So companies that don't normally share data can share data to help the ecosystem. So what would that mean? Well, we talked about precision medicine, genomic data, clinical research data, clinical care data, personal lifestyle data. All these come from different places. What about some real examples with blockchain? There's an application called TradeLens, which was built with Maersk, a big shipping company worldwide, and IBM. And they have hundreds of participants. They have shipping companies, they have port authorities, they have customs offices from different governments. So different organizations from different places that wouldn't normally share their data with each other, but they participate in this blockchain-enabled capability and system so they can keep track of the shipments. What would some of the value be? Well, it doesn't have to stay in port as long. If they have all the data, they validate the data and they let it keep going. So higher efficiency, lower latency, not just not IT latency, but like, shipping latency. When you're waiting for something, you can get it faster. I was talking to a couple of gentlemen. I was speaking up in Canada, and I was with these longshoremen, the guys who actually work on the shore, and they're the ones holding paper that's blowing in the wind during a blizzard and trying to validate, the shipping information. They said this would be great for them because, the papers fly away, all sorts of stuff happens. And if you think of the people shipping the information or shipping the products, a lot of things they say fell off the truck, you ever heard that, or fell off the boat, which means somebody may have taken them. With the blockchain technology, because it has data provenance and you can see where the transaction changed potentially, where the information changed, like, oh, there were 100,000 of these devices before it went into Halifax, and then there were 30,000. Oh, really? What happened in Halifax? So you can actually look at the data and keep track of it. And so you could reduce what they call shrinkage, so stuff isn't stolen or falls off the truck or the boat. It tracks, but the issue I have is that they say it's basically immutable. So basically immutable is not equal to immutable. So I'm an aerospace engineer, so I designed airplanes and space shuttle wings and stuff, right? So if someone were to ask me, is the plane going to fly? And I said, basically. Would you want to get in that plane? I don't think so. So that's how I look at this. Basically, immutable is not immutable. And people who are coding this for healthcare applications, as an example, and somebody else I know who's creating an off-chain capability, are actually making sure that the data is kept off-chain as much as possible and that they're able to maintain control of the blockchain. A gentleman I worked with at IBM who has a healthcare startup is actually deploying these blockchains, and he makes sure in the solution he is delivering that he always owns 51% of the nodes, because that's the magic number. 51% of the nodes can be in collusion and actually get data onto the blockchain that might not be true. But it does keep track of where some of these changes happen, so you can go figure them out. So the value of blockchain is it's a distributed multi-party ledger with an append-only structure. You can add data. You're not supposed to be able to change it, but I think there's a lot to be certified on that still. That's another effort we're starting with IEEE. It has data provenance, tracks the data, where did it change, where's new stuff, who is involved with it. I'm still concerned about the 51% rule where it's basically immutable, but not really. It enables the use of smart contracts and incentives for data sharing, so it helps people say, wow, look at the value of data sharing, but how do I know I trust these people? So they have smart contracts so they can make sure that they're managing it the right way and incentives to do that. And it might add some of these TIPPSS capabilities if deployed correctly. What are some of the challenges? Data can be hacked before it even gets on the blockchain or gets connected to the blockchain. Some people don't realize that. The blockchain itself could be hacked because it's not really immutable, and so you need defense in-depth strategies. There's also some research going on, a couple of gentlemen at the Rochester Institute of Technology, on application collusion. Not only are humans colluding, but applications are colluding. And this could be happening more and more. And so if you wanted more information on that, there are a couple of gentlemen at RIT, and you can send me an email, I can connect you with them. So blockchain may be part of the solution for TIPPSS, but it could also add some risk. We're looking at it for Internet of Medical Things and clinical IoT, as I mentioned. We're also looking at it for the pharmaceutical supply chain to see, and I was talking to a gentleman from Nigeria, and he was saying, how could this help in Africa? When I was at IBM, we actually were already working on the pharmaceutical supply chain in Africa and trying to improve the data provenance of the supply chain and maintain the actual real products as compared to counterfeit products. So this could be used to keep track of that as well. There are a number of health IT leaders that are experimenting with blockchain. You can see the Synaptic Health Alliance, and those are actually the Aetna, Ascension, Cognizant, Humana, Optum, Quest. So Quest actually does laboratory results, testing results. United Healthcare is one of the large healthcare providers. Aetna, Optum, Cognizant as a solution provider, software and consulting. So there are a lot of them, and what they're doing is a first ecosystem play where they're all participating together, and the first application they're looking at is a provider directory. So it doesn't touch any humans and insulin pumps and pacemakers, but it allows them to see if they can create a shared blockchain environment where they keep track of provider, which is doctor information, so that they're all sharing it appropriately between the payers, providers, and each other. This is the Blockchain Healthcare Today journal I told you about. It's an open, peer-reviewed journal. You can download any of the manuscripts on it if you want to learn more about potential blockchain uses in healthcare. And then I led the pre-standards work on clinical Internet of Things data and device interoperability with blockchain actually for IEEE. And as we did this work, and it had a number of really cool participants, you could see we had Ascension, Bayer, or Bayer, depending on how you say it, Cognizant, IBM, IEEE, Indiana University Health, Intel, Medtronic, the US Food and Drug Administration, Oracle, Spiritus, another University of Buffalo, and wireless experts out of the Research Center of North Carolina. And as we went through this, we said, you know, blockchain is not immutable. Blockchain could have some risks associated with it. You don't have to use blockchain for clinical Internet of Things, data and device interoperability. So what we recommended is that we create a new working group to create a standard, and so we're about to announce a 10-year standards effort called Clinical Internet of Things, Data and Device Interoperability with TIPPSS. This will be an open group. It's at the individual level. I don't even think you have to be an IEEE member. So if any of you are interested in being on the interested parties list, because I want it to be a global group, because this will affect the whole planet, not only are a lot of the devices used around the planet, but the humans travel around the planet, and their devices are going to be connected wherever they go, pretty much. So I would love it. You can send me an email. This is my forever email from my alma mater, flow1980@alumni.princeton.edu. And I can put you on the list of interested parties and send you an email when we announce it. It'll probably be this summer. So someone asked me, is this going to be a technical talk? I said, not exactly, but I'm going to add some technical stuff for the people who talk at this level. In the Boston event I recently went to, I was going to keep it high level, but then people started, who know healthcare, were starting to talk about the integration layer you see there. FHIR is called FHIR, HL7, CDAs, Jello, SNOMED. So these are standards. As they say, the beautiful thing about standards is there are so many of them. And so there are a number of standards opportunities. And what we have to look at, if we're going to create this, clinical IoT data and device interoperability, start at the user experience and user interface, because patients and providers, doctors, nurses need to use this stuff. Application layer and integration layer, APIs and SDKs. Distributed ledger technology as appropriate, a connection layer, data ingest and management, as well as data sources and targets on-chain and off-chain. We also have Hyperledger folks involved with us as well. And then up and down the stack, security, encryption, federated identity management, key management, all the TIPPSS elements. So this is what we're going to use as a base. We're looking at publishing this, this report with this draft in the Blockchain for Healthcare Today journal, and then we'll use this as a base to get the working group started that will be sponsored by the IEEE Standards Association. And all smart, caring people are welcome to attend. We actually have a book coming out on this. This is kind of a miracle that happened to me. One of my friends created the Women in Engineering and Science series at Springer Nature and Springer Publishing in Switzerland, and asked me to be editor-in-chief for a book, so I said yes. And I have 16 other women from around the planet that are authors in this book with me. And it'll be coming out next month. And it's Women Securing the Future with TIPPSS for IoT. And here are some of the chapters in it. A woman from Cisco wrote one on IoT, is it a digital highway to security attacks? I have a judge from Colorado that's talking about privacy, security, and your civil rights, including information from the US Constitution and GDPR. You can see privacy in the new age of IoT, GlaxoSmithKline out of the UK. One of my girlfriends at CERN, who's an information security fellow there, she's talking about security for science, and a number of others, as you can see. So it's about 198 pages, and I'm very proud of them. I think they're going to be really honored to be in it, and I think it's very interesting to read, because we talk about storage, as you see in Chapter 12. We talk about pervasive encryption, which is at the hardware and system and server level, privacy management, public safety, which is like smart cities, security for science, and many other elements, as you can see. So that's what I wanted to share with you today. I hope you found it interesting, and I'd be happy to take a question or two. I think maybe we have a minute.
Okay. Anyone in the audience has any questions? There's no questions here.
They must know everything. That's cool.
Yeah. Okay. So another applause for Florence, please.
Thank you.